Alrighty, students, going to get a little logarithms on today. Now, logarithms are just another fancy way to write exponents. They've got some handy things for you to figure out where everything goes. We're just going to start working problems. So, the way this reads, from log to exponent form, 2 to what power is 32? Well, it's 2 to the 5th power. 2 to the 5th power is 32. 10 to what power is 1? 10 to the 0 power is 1. 9 to what power is 9? 9 to the 1st. And this is going to come into play later. You'll notice that those two kind of cancel out. When you have log base and that same number is up here, it's equal to 1. That'll come into play just a little bit later. And then this one, fractions with your negative exponent, if you want to get to the top, you just slap a negative exponent out there. It's 5 squared is 25. We have a fraction, so we want to slap up that negative exponent to make our fraction go into a whole number right there. Evaluating the logarithm, 3 to what power is 81? It's 3 to the 4th power. 1/4 to the what power is 256. Now I know 4 to the, what is it going to be, 4 to the 4th power is 256, but this is 1/4, so we're going to have to go to the negative 4th to make that happen. 10 to the what power is the, what is that, 1,000? I think it's a 1,000th. This is 10, negative 1, negative 2, negative 3, negative 4. So 10 to the negative 4th again. And then the last one, 64 to the what power is 2. And so this is going to be a, if you think about it, 2 is the 6th root of 64. So if I had this, that would be 2. It's just going to be fractional, 1/6. So 64 to the what power is 2. We need that 6th root, so we're going to take a fractional exponent. The log button on your calculator is just base 10. You can change the base using some fancy things, but the log button itself is just going to be base 10. So when we ask you to evaluate, it's this easy. We've got log 0.85, and so 10 to the what power is 0.85. It's going to be this one right here. They want to the 10,000th, so 4 decimal places, 10th, 100th, 1,000th, 10,000th. And you could check it. This should be 10 to this power is 0.85. So if I take 10 and raise it to that power, boom, check that out, 0.85. Natural log involves e, and we'll talk more about e later. It's just your other log function on the calculator. Sometimes natural log is better to use than your 10 log. This one again, 4 places after the 0. 0, 9, 1, and then 0. That tells us, hey, I could be this accurate, but there was nothing there. Alright, moving right along. You've got some action right here. Most of our application problems, logs, really, most of the time you come up with this equation and then you use it. We have an equation with our log. It's giving us some video game sales, and we're just dumping it in. X is the number of months. We want 10 months after, and it's a straight up drop it in. See what you get. Could have put a 9 in there. A little lazy, my bad. And done. That's it. So 79. 79,000 video games. Estimate the number. Done. Just drop it straight into the calculator. Now, this is where it gets a little crazy. We've got inverses. Inverses. So example, this is 1. What happens to this 4? This e to the ln is 1. What happens to that 9? And if you recall, if I've got an exponent and I raise it to another power, it's just a multiplier, right? And so what that ends up doing is this simply becomes a multiplier. So if you remember from the previous page, you've got, log 9 of 9 is 1. You have log 3 of 3. This is going to be 1. Well, how many of those do I have? I've got 4 of those. So I can swing this out in front and say that this is 4 log 3 of 3, these are going to cancel and leave me with a 4. How do we make that apply here? I'm going to change 27. I'm going to change 27 to 3 cubed. So 3 cubed to the x. So now I've got log 3 of 3 to the 3x. This is come out in front as a multiplier. Log 3 of 3 cancels. And we're ready to go. E to the ln, anything that comes after that ln is going to be the answer. It basically says e to the whatever it takes to make a 9, and that's, I mean, check this out. So we get a little e up there. E raised to the ln 5 is 5. E raised to the ln, 2.39 is going to be 2.39. It's a cancel. It's a straight cancel, releasing our exponent. Now, Desmos is a great way. If you struggle with what I'm about to do, Desmos is a great way to get a visual of your graphs. Some of you guys are going to panic a little bit. You're going to be like, oh no, it's okay. It's the same thing we've been doing. You just have a basic shape. All right? If we have a whole number as our base right here, this side is your what happens after you square, and then this is going to be your exponent. All right, let's give it a chat. Let's give it a chat. Here we go. Again, if you struggle, Desmos is a great way. So I know my shape is like this. I have no adjustments to my starting point. You'll notice we'll have some adjustments here later, but I have no adjustments to my starting point. If I have an exponential value of 0, the y's are going to be my exponential value. The x's are going to be, what it takes to have that exponential value. So exponential value of 0 with a 2 is 1. Exponential value of 1 with a 2 is 2. Exponential value of 2 with a 2 is 4. So I've got that same exponential curve. It looks very similar to a square root function because of the 2, but because it's a log, we can go negative on it. So those points that I used, x, y, remember x is my resultant value. To get a 1, I need to have a power of 0. To get a 2, I need to have a power of 1. To get a 4, I need to have a power of 2. Those are the points that I used. Now I'm going to go straight to this one because it's got an adjustment. So I'm going to the right 2 just like I do always. I'm going up 4 just like I do always. So again, I would start here at 1, 0. I'm going to move that starting point just like I did here. I'm going to move that starting point over 2 and up 4. And so I'm going to imagine that my y-axis is right here. I just moved that parent function. I've got no multipliers on this. I imagine that my x-axis is right here. And then from there, if I have an exponential value of 1, I would get a 3. If I have an exponential value of 2, I would get a 9, and we're already off. My asymptote is still right there at the -2. Boom. And I'm just gonna drop those points in. So x, y. To make that 0 on the inside, or to make that 1 on the inside, I used a 3. And then anything to the 0 power, so this is going to be a 4 right here. And then when I went to my next y value of 5, that's when I had plus gracious, another plus, so that's going to be a 5 right there. So I went from 1 to 3. Anyway. Desmos, great way to hook that up. Now, last one. Hard one. You've got that fractions. I'm going to spend a lot of time here in the negatives because it's easy to do. This is going to end up tailing off. So this one goes like this. The fractional ones will go like this. All right, fractional ones will go like this. So we got x, y. Remember that x is your resultant value. Y would be the exponential value you use if you're going a little backwards. At the end of the day, this is 2 over 3 to the y is equal to x, if I were to rewrite it. So, if y were 0, x would be 1. It's an easy one because we haven't been adjusted left or right. If y were -1, because again we're going down to make it come up, these, I mean I can draw this right now, we're just going to get really, really small as we get larger and larger exponents on this. But negative exponents going to give us some numbers that we can use. So 3 over 2. Alright, 2 over 3, the negative first is 3 over 2, so I've got another dot. Negative 2, 9 over 4, so a little bit more than 2. Negative 3, 27 over 8, so a little bit more than 3. Close to 3.5. And then negative 4 is when we start popping up. We have 81 over 16. So, I don't know, 5-ish. So there's 3, 4, 5-ish. And then we'll start getting big. We'll get 243 for negative 5 over 32. And that's going to be 7 and some change. And there's my tail coming up. Boom. Looking just like that. Again, if you have trouble with these, Desmos is the way to go to get a visual. You will have to do this on your own. So I would use some kind of calculator or Desmos to start, but I would make sure you can do this by hand. And it's this shape. They get moved around the exact same way that we would move other things around. It's the inverse of an exponential. All right? Good luck.